All right. So we've talked about how lifting weights or doing resistance exercise can increase muscle mass and strength, and how it's going to have all of these components of it, of force transfer, of the molecular signals that are there, whether it's mTOR, or whether it's myostatin, or whether it's satellite cell activation. But we haven't really talked about probably the most important reason that we should do resistance exercise, and that's really to minimize injury. And so what your strength training is going to do and what this series of videos is going to show you is how your strength training is going to be good for minimizing injury risk. All right, so by the end of this lecture or this series of videos, you should be able to describe the role that a tendon plays in the body, draw the stress strain curve of a normal tendon, and that means not only what the overall stress strain curve is, but also the regional stress strain curve. Explain how the curve changes with speed, because these tissues are viscoelastic, like most biological tissues in your body. Explain how the stiffness of a tendon is dependent on its activity level. Define passive and active stiffness. State and define and really compare and contrast different exercises for exercises that increase stiffness and exercises that decrease stiffness. You'll be able to describe a nutritional intervention that can increase collagen synthesis and a program that can reverse tendinopathies, right? And as part of this, and this is active research that we have going on in the laboratory, I'm going to have one of my PhD students come in and give one of the little videos so that you can see the data that she's collecting, so that you get data that's not even been published yet. All right, so what do I mean by strength training is important for preventing injury? So this is what's called a meta-analysis. This is an analysis of hundreds of different studies, or lots of different studies. I don't think it was hundreds, but it was thousands of different participants. And the idea here is that they wanted to look to see what are the things that could decrease the musculoskeletal injuries. And so they looked at studies that did stretching, proprioceptive, strength training, or combinations of a lot of different things. And the strength training was specifically heavy strength training. And what you can see here in this graph is that this is your average risk without the intervention of 1. So if there's a significant effect, it should either move to the right or the left. If it moves to the right, you're increasing the risk of injury. And if it moves to the left, you're decreasing the risk of injury. So when you stretch and you just go down and you passively stretch and hold a stretch, there's actually no decrease in the rate of injury, because the line for stretching is right at this relative risk of 1. It's the same as if you didn't do the intervention at all. When you look at strength training, heavy strength training is decreasing the risk of injury by almost 2/3. So we're looking at about here, that's about 0.33, that's 33%. So that means that 67% of the injuries have been mitigated. So that when in this meta-analysis, what they're looking at is they're saying, what's the rate of injury prevention that comes with these different interventions? Strength training is the best of all of these different interventions for decreasing musculoskeletal injuries. And it's decreasing it by about 67%, or about 2/3. So you're about 2/3 decrease in the rate of injury simply by doing heavy strength training. So the question that we're going to answer in these videos is why, and how is this working? And what is the mechanism underlying this? And we're not going to necessarily get into the molecular mechanism here. We're just going to talk about the cellular mechanisms as to how the tissues that are involved in this, how the tissues that we're looking to adapt, are adapting to strength training in a way that's going to promote musculoskeletal health.